Did you guys realize that the sales of Apple iPhones is actually correlated to the number of deaths of people falling downstairs? How do I know interesting facts like this? Well, I'm a data scientist. I have been for, well, actually I've been in the business for quite a long time, over 20 plus years. And what I want to do today in this talk is just share some of the interesting things about my job with you guys. So a big part of my job is understanding correlations in data. Two-dimensional correlations are pretty easy to understand, and humans are very good at them. The real issue is with multi-dimensional correlations. But hey, let's try you guys on a few correlations to see whether you're awake or not. So if I asked you, does the per capita consumption of cheese in the US correlate with the number of deaths by people getting wrapped up in their own bed sheets? Is that true or false? Anybody like to guess? Actually, it's true. How about the number of Oxford graduates versus the number of deaths in Harry Potter films? True or false? Actually, that one's false. I kind of made that one up. And how about another one, just to make kind of life interesting? How about the consumption of cheese in the US versus the number of divorces in Washington? Actually, that one's true too. But data itself is very interesting. And my job as a data scientist is to try and put a human spin on these sort of weird correlations. But as I said, moreover, to do the multi-dimensional stuff. Okay, so data can be truly weird. And one of the things I find about it is that you sit down with the business user and you start with a hypothesis. And then this amazing piece of art, which I'm just showing you here, really sums up my business. And so you start with one hypothesis, you start paddling around in the data, and you see something completely different. Isn't that wonderful? I got really excited when I saw this, because I said, that's my job. This is it. So here you go. And that really sums up data science for me. You get something new from the data every time. Some years ago, I got some data from an insurance company. And what happens when you get data? It gets unloaded at one end, and then you load it up at your end. And then you start doing some stats on it and start trying to understand what's in it. You actually have to sort of learn the data set. And it's sort of very much a human trait. And what happened in this particular case is, well, let me tell you what really happens is that you get data in, and then you get an offset in the sort of columns. So either a few characters get inserted halfway down or long way down, or they get taken out. And then what you get, instead of the columns being nice and true and straight like this, what you end up with is what I call the spiral of death. And we've all seen that, I'm sure. And so you end up with the data, and you look at it, and it looks all sort of spirally like this, where the data's got offset, and it's a mess. And you've got to try and work out how to get it back again. So in this case, I didn't have that problem. So the data looked straight and true. But I had this column labeled sex, which I guess probably in this PC world, we probably should label gender. But in that time, that was what the guy had labeled it from this insurance company. So I couldn't make it up. I had 5 discrete values in this column. And I didn't have any encodings for the data, so I didn't know what to do about it. So in the end, I rang the guy up, and I said, look, I've got a real problem with this data. I don't understand this column that you've got in the data called sex. And I said, you've got 5 different values. And he said, oh, yes, he said, we've got 5 different types of sex here. And I said, really? Oh, that's interesting. So can you explain what they are? And he said, well, we got M for male, F for female. And I said, well, that sounds fairly normal. And that's sort of what I'd found. He said, we've got U for unknown. I said, okay. And he said, well, then we've got N for a non-person. So I said, well, what in the world's a non-person? He said, well, sometimes we can only get the gender by looking at the title that's been filled in the application form. And what we got there is that we've either been given a reverend or a doctor, and obviously you don't know what the gender is then. So the other thing, I said, well, what's the final one then? Oh, he said C. He said, that's company. And I said, all right, okay, thank you. So you can see you get some real issues. But gender in itself is very important to insurance companies. And the reason it's very important is that, sadly, we know certainly in the US, and it's also true in Europe, that transgender people are more likely to commit suicide. In fact, in the US, the rate is about 41%, which is very sad. And what that means for an insurance company, it's very important to understand gender so that they can get the correct pricing and understand the correct risk profile for these insurance companies. You guys probably know that IBM's got quite a good relationship with Twitter, quite a strong partnership, and I get to work with Twitter data quite often. It's a very biased sample, as any of you have probably worked with it will know, and you have to be very careful with biased samples in data science. I've heard people talk about Twitter as the vocal minority, and I think that might be true. But anyway, I think a good example of that, how you can get into misleading results, is the Scottish referendum. So if you drew a network graph of the hashtags during the actual referendum, what you saw was that and it was rather strange too, because yes actually meant that they wanted to leave the union. I think there was a lot of controversy at the time how they'd phrased the questionnaire. And better together was actually the one you wanted them to take, which actually they ultimately did, as we know. But if you looked at those hashtags, yes and better together, and any of the equivalents around them, what you saw was about 28,000 people in the yes, we want to leave camp on Twitter, and then you saw about 16,000 odd in the better together. So you sort of instantly conclude, if you didn't think of any more about it, as that sample was telling you that they were going to leave wholesale and it was going to be a game over for the union. If you wanted more support for that and you went off to look at the actual leaders of it, there was Nicola Sturgeon. She had 34,000 followers at the time. And Alistair Darling, who had the catchy tag Together Darling, which to me sounded a bit like a Blackadder sketch, had only 9,000. So again, you'd be led to believe that this was what was going to happen. So here what we've got is some work I did on anti-money laundering in Kenya. And this will show you that sometimes it's very difficult to explain what's going on. So here you can see there's a big fat line that runs right from Mombasa on the coast over there up to the middle. And if you zoom the map out and look under the Kenya, what you can see is just a bunch of subsistence farmers. And it's very explained. And the only explanation our team could come up with was that what was happening was that you were sending their siblings to the coast for work, and then they were sending money back to the parents. But sometimes it's not particularly clear. We showed this chart to the Gates Foundation at the time, and what they were interested in, interestingly enough, was whether or not we could use this type of data to predict where famine was occurring. And obviously, if you get a sooner intervention in the famine, then you can do something good for humanity. And it's really nice to see that you could use data in that way. Let me conclude by saying a couple of more things. So when it comes to data science, one of the most exciting things that's happened of late has been Spark for me, because now I can really get in there and I can process all the data. I can do great temporal analysis. And data science is very addictive, or at least I find it. And what happens is that you end up with more data. You want to process more and more data. And of course, you normally get stuck processing aggregates, which is fine on some occasions, but not in every occasion. But this is, to me, really great. Final thought. How many data scientists does it take to change a light bulb? The answer is 4. The first one comes along, and what he does is he does the business requirements of the business user, comes up with a hypothesis. The second one comes along, and he gets some data in, probably gets some data from an external data supplier, like the utility companies on the outages. The third one comes along, does some machine learning, tests the hypothesis out. The fourth one comes along, and he will go back to the business user, tell him he needs to change the light bulb, and he probably needs to use an LED light bulb because it's going to last him 25,000 hours. Thank you very much. Please come and talk to us on our stand 202 about our endeavors in big data. Thank you very much indeed for your time. Ladies and gentlemen.